we discussed acid-base reactions, isn't it?
Yes,
and we started yesterday.
Yes, ma'am.
We talked about acid.
Yes, ma'am.
I said acid is any substance that dissolves in water to produce hydrogen ion and hydrogen ion and hydrosodium ion as the only positive ion, isn't it?
Yes.
So I went further to talk about organic acid and inorganic acid. The organic acid are those acids that is gotten from our natural sources, such as plants and animals, isn't it? The inorganic acid are synthesized from minerals, and that is why they are referred to as mineral acid. You can also refer to them as man-made. We went further to talk about the sources of those acids. I think I gave you some examples, isn't it?
Yes, ma'am.
So we also talked about the preparation of acid, isn't it?
Yes, ma'am.
The physical and chemical properties of acid, and we started base, isn't it?
Yes, ma'am.
So from our yesterday definition, what did we define? How did we define base?
The base is any substance that dissolves in water due to ion
Negative ion.
Base is any substance that dissolves in water to produce hydroxyl ion as the only negative ion. And I said base are what? Base are oxides or hydroxides of metals, isn't it?
Yes.
So, and I gave you, is the erroneous definition of base.
Yes.
And what was that?
A base is a substance which reacts with hydrogen ion or hydrogen ion
To produce water, isn't it? Then we went further to talk about the Rosten-Lorentz definition, isn't it?
Yes.
So and what was that?
A base is a proton acceptor.
It is a proton acceptor. So this morning we'll be going to Lewis' concept of a base. Are we together? Lewis defined a base as electron pair donor. Electron pair donor. If you look at the definition of acid and that of a base, they look like words and what? Words and opposite. So Lewis defined a base as what? Electron pair donor. Are we together? So they are the species that possess a lone pair of electrons. Is that okay? So let's look at these examples. They are the species that possess a lone pair of electrons. The lone pair of electrons, is it taken? All right. So if you look at this, look up, are we together? If you look at this nitrogen has lone pair of electrons, isn't it? Are we together? Did you know that nitrogen has lone pair of electrons? So the lone pair of electron is donated in this case. Is that okay? Are we together?
Yes, ma'am.
Did you get that?
Yes, ma'am.
All right. Let's look at the physical property of a base. Physical property of a base. You should note that, in the last class I said you should note that these are what? These are weak electrolytes. So that is one of their property. They are weak electrolytes. Physical property, please. They are weak electrolytes. They have soapy and a slippery feel. Soapy and slippery feel. Slippery, sorry, soapy and slippery feel. Yes. They are weak electrolytes. They have soapy and slippery feel. Feel. To feel something. When you touch it. Are we together? And they have bitter taste. They have bitter taste. What is their effect on litmus paper? They turn red litmus paper blue. So let's look at their chemical property. Chemical properties of base. Chemical properties of base. A base will neutralize acid. A base will neutralize acid. For example, sodium hydroxide. For example, sodium hydroxide neutralizes hydrochloric acid. Neutralizes hydrochloric acid to produce sodium chloride, which is salt, and water. Are we together? A base will neutralize acid. And I said, for example, sodium hydroxide neutralizes hydrochloric acid to produce sodium chloride and water. So this is the equation. The sodium hydroxide.
Hello. Now listen, everybody. Those that are live are complaining. Those that are watching us from different parts of Nigeria are complaining that the noise is much. We don't have another microphone for now. We don't even have.
Are we together?
Microphone for now.
Is it taking? Let's look at another example of neutralization reaction where our base is neutralizing the acid. Is that okay? So copper 2 oxide. Is it taken? Copper 2 oxide, a black solid, dissolve in dilute tetrahydrosulfacic acid. Copper 2 oxide, a black solid. Under neutralization, I've given you the simplest one, the one you're familiar with. That is a reaction between hydrochloric acid and sodium hydroxide to give you sodium chloride and water. Now I'm giving you another example. So copper 2 oxide, and copper 2 oxide is a black solid. Are you with me? So copper 2 oxide, a black solid, dissolve in solution of tetrahydrosulfacic acid. Dissolve in solution of tetrahydrosulfacic acid. Are we together? Dissolves in solution of tetrahydrosulfacic acid to produce a solution. To produce a solution of copper 2 tetrahydrosulfacic. A solution of copper 2 tetrahydrosulfacic. So this is copper oxide reacting with H2SO4 to give us copper sulfate and water. Is that taken? Any question? Are we together?
Yes, ma'am.
Okay. That is one of the chemical properties. Let's go to another chemical property. Are we together?
Yes.
So you can take these two. Yes. Okay. Number 2. Aqueous solution of alkali. That is another property. Aqueous solution of alkali. Turn red litmus paper blue. Turn red litmus paper blue. And the reason why aqueous alkali can turn red litmus paper blue is because of what? Because of the production of hydroxyl ion when it is dissolved in solution. Is that okay? All right. Production of hydroxyl ion. Are we together?
Yes, ma'am.
All right. Number 3. When a mixture of alkali and ammonia salt are heated, when a mixture of ammonia, an alkali and ammonia salt are heated. Are we together? A colorless gas with pungent smell. A colorless gas with pungent smell is given off. And that gas is which gas? That gas is ammonia gas. Is that okay?
Yes, ma'am.
That gas is what? Ammonia gas. So let's look at this equation. So this is potassium hydroxide plus ammonium salt. In the presence of heat and potassium chloride serving as a catalyst. No, sorry. It is not catalyst, please. That is the product. So this is the gas that is being produced. The gas that is giving off, that gave us that project smell is what? Is the ammonia gas. Is that okay?
Yes, ma'am.
Are we together? Number 4. An alkali neutralizes an acid. An alkali neutralizes an acid anhydride. Yesterday I told us what acid anhydride is, isn't it? And what is that?
Oxide of non-metal.
They are solutions of what? Oxides of non-metals. Is that okay?
Yes, ma'am.
Is it taken? E.g., when carbon 4 oxide is passed into, when carbon 4 oxide is passed into aqueous sodium hydroxide. Aqueous sodium hydroxide. A solution of sodium tetraoxocarbonate, take sodium trioxocarbonate 4. A solution of sodium trioxocarbonate 4 and water is produced. Is it taken? A solution of sodium trioxocarbonate 4 is produced. So this is the equation of a reaction. This is ammonia. This is a sodium hydroxide reacting with CO2, that is carbon 4 oxide, to give us. Are we together? Are we on the same page?
Yes, ma'am.
Is it taken? So that is the equation of reaction. Let's look at the strength of base. Strength of base. Subtopic. That's another subtopic. That is that about the chemical properties. Strength of a base or alkali. Are we together? Like we have a weak acid and weak base, isn't it? We also have strong acid, strong base and weak base. So strong base are those ones that does what? They ionize completely in water. Is it taken?
Yes, ma'am.
Strong base are the base that ionize completely. That is, they undergo complete ionization in water. Are you with me?
Yes, ma'am.
Are we there together?
Yes, ma'am.
All right. Let me give you examples. Examples of strong base. We have sodium hydroxide. Sodium hydroxide. Potassium hydroxide. And the barium hydroxide. Is it taken?
Yes, ma'am.
Are we there together? All right. Now weak base. Weak base. These are bases that undergo partial or incomplete ionization in water. They undergo partial or incomplete ionization in water. In water. Are we together?
Yes, ma'am.
Example. We have calcium hydroxide, magnesium hydroxide, and ammonia. Are you with me?
Yes, sir. Yes, ma'am.
So let's go to preparation. Preparation of base. Preparation of base.
Now,
Are we there?
Yes, ma'am.
Preparation of base. There are different methods we can use to prepare base. One, combustion of a reactive metal in air. Combustion of a reactive metal in air. Combustion of reactive metal in air. AIR. Is it taken?
Yes, ma'am.
A reactive metal born in air to give oxide. A reactive metal born in air to give oxide. For example, sodium born in oxygen to give sodium oxide. Sodium, that is sodium burning in oxygen to give what? To give sodium oxide. Is it taken?
Yes, ma'am.
Are we there? Number two method. That is how we can prepare base. When this is an example of metal. When it burns in the presence of oxygen, that is, it undergoes combustion reaction, isn't it? So it is going to give us oxide. Are we together? It is going to give us a metal oxide. Then another one, number two, action of soluble base in water. Action of soluble base in water. Is it taken?
Yes, ma'am.
Action of soluble base in water. Soluble base reacts with water to give hydroxide. Soluble base reacts in water to give what? To give hydroxide. So let's look at this. This is calcium hydroxide. This is calcium oxide. Plus water to give us calcium hydroxide. Are we together?
Yes, ma'am.
Is it taken? So when calcium oxide reacts in water, it is going to produce calcium hydroxide, and that calcium hydroxide is a base. Yes. Sorry. Are we there? Number three. Action of reactive metals on cold water. Action of reactive metals on cold water. Action of reactive metal on cold water. Action of reactive metals on cold water. Cold water. Are we together?
Yes, ma'am.
So soluble bases are prepared by the action of metals on cold water. For example, don't write that now. You're repeating the same thing. I just said action of reaction on cold water. Isn't it?
Yes, ma'am.
So let's look at the example. Sodium metal, they react violently. That is, the reaction is very fast. Is that okay? They react violently with cold water to produce a colorless odorless gas. Are we together? No. All right. I said action of reactive metals with what? With cold water. An example of that is the reaction of sodium with cold water, and that reaction is vigorous. Are you with me? Are we together? Somebody still saying no? Yes. I said when you react metals, the reactive metals with cold water, the reaction is usually very vigorous. Is it taken now?
Yes.
So and it is going to produce colorless, odorless gas. And that gas that is being produced is hydrogen gas. Also, an alkali will be produced. Colorless, odorless gas. And that gas is hydrogen gas. The gas is hydrogen gas, and alkali is going to be produced at the same time, isn't it? And that alkali that is being produced is sodium hydroxide. Is it taken? Are we all together? So let's look at the reaction. This is sodium reacting with water to produce sodium hydroxide and hydrogen gas, isn't it?
Inside.
Is it taken? Okay. Are we together now? All right. Another method of preparing acid is a precipitation method. Base. Another method of preparing base is precipitation method. Precipitation method. Is it taken? Insoluble hydroxide. Insoluble hydroxide are precipitated. Insoluble hydroxide are precipitated by the action of sodium hydroxide. By the action of sodium hydroxide. By the action of sodium hydroxide. Are you with me? Insoluble hydroxide. Insoluble hydroxide are precipitated by the action of sodium hydroxide on aqueous solution of their salt. On aqueous solution of their salt. Is it taken? I said insoluble hydroxide are precipitated by action of sodium hydroxide, by action of sodium hydroxide solution on aqueous solution of their salt, that is their own salt. Is it taken? So let's take example. For example, when excess sodium hydroxide, when sodium hydroxide solution is added to a solution of copper 2 salt. Are you with me? Solution of copper 2 salt. A blue precipitate of copper 2 hydroxide is obtained. A blue precipitate of copper 2 hydroxide is obtained. So let's look at the equation of that reaction. So sodium hydroxide reacting with copper sulfate. This is the salt. Is it taking? Are we there together?
No, ma'am.
Can I continue? No one is saying no?
Yes, ma'am.
I hope I'm not blocking your view. Number 5, decomposition reaction. We've just talked about precipitation reaction, isn't it?
Yes, ma'am. Yes, ma'am.
Now we are going to decomposition reaction. So, insoluble basic oxide, please. Insoluble basic oxides are obtained by the action of heat on metallic hydroxide, trinitrate 5, trioxonitrate 5. Are you with me? I said insoluble basic oxides are obtained. Insoluble basic oxides are obtained by the action of heat. On metallic hydroxides. By the action of heat on metallic hydroxides. Trioxonitrate 5. Excuse me. Sorry about that. Shall we?
We shall.
All right. I said insoluble basic oxides are obtained by the action of heat on metallic hydroxide, trioxonitrate 5, and trioxocarbonate 5 salts. Are we together? Okay. We'll look at the reactions. I'll write down the equation of reactions. So I said insoluble basic oxides react with what? React with metallic hydroxide in the presence of heat. Look at this, and I gave you some examples. Isn't it? I gave you trioxonitrate 5, trioxocarbonate 4, and hydroxide. So look at this. This first one is for the hydroxide, isn't it? The second one is the first one is not balanced.
Sorry, that aluminum hydroxide. Yes. When there is no like many base, does it need to be back?
Is it balanced now? Is it balanced?
No, man. Ma, they are for oxygen, yes. They are creating oxygen.
Actually,
It's still So, yes, all the three equations we have there are decomposition reaction. Are you with me?
Yes,
They
ma'am.
are decomposition reaction.
The arrow is going to be reversed.
No.
No.
Yes,
One person at a time.
Yes.
If it's the composition reaction, the arrow is going to be reversed.
Yes. You can leave it like that. Is that okay? Yes, you can leave it like that. No, it's not the dissociation that is reversible. The composition too is also reversible. You get it? Huh? Yes. Yes, it is. This is of alkali. Is this taken?
Yes, ma'am.
What is taken?
Ma'am, what's formula for
Cash, that is calcium hydroxide.
how I like lime water?
I know them so when help.
Lime water is
Lime water. Slick lime is C, calcium hydroxide. Then calcium, then the other one is CaO. This is that okay? So let's look at the uses.
No.
It is used in the production of soap. It is used in production of soap. Soap. It is used in production of soap. Papers. Yes, papers. So, which type of base do we use in the production of soap, paper, and the like? We use sodium hydroxide and the caustic potash. Huh? KOH. Are you with me? Caustic potash. Are we together? I said it is used in the production of soap and papers. and the type of base or the type of alkali that are used in the production of potash, in the production of soap and paper is sodium hydroxide and caustic potash, that is KOH. Is it taken? Another one, calcium hydroxide. Yes. I'm talking about the uses now. Calcium hydroxide. That is the slicked lime. The slicked lime. It is used in the production of fertilizer. It is used in the production of fertilizer. And why did they use it in the production of fertilizer? It's to neutralize the acid that is present in the soil. Is that okay?
Yes.
Because it is a base. It is used to neutralize the acid that is present in the soil. Then another one is magnesium hydroxide. Magnesium hydroxide is used. Magnesium hydroxide. Sorry. Magnesium hydroxide. This is the formula. There is a subscript of 2 there. It is used as laxative agent. Laxative. Is it taking? I'm coming to that. It's used as laxative agent to neutralize excess acid. To neutralize excess acid in the stomach. To neutralize, so it is used in production of certain drugs. Are you with me? Like at times you have constipation, isn't it? And you're unable to go to the toilet. You take some drugs to ease the bowel movement, isn't it? So those drugs that ease bowel movement and enable you to go to the toilet easily are laxative agents or laxative drugs. Even some plants, because most of these drugs they are synthesized from the what? From the plant. Some of those plants has these laxative materials in them. Are we together? So ammonia solution, that's another one. Ammonia solution is used in the laundry. Ammonia solution is used in the laundry to neutralize the acid in the body sweats. Acid in the body. Put hyphen. Acid in the body. Put hyphen there. Sweat on clothes. So that is the reason why it is used in the laundry. Is that okay? By the time we secrete sweat and we take the clothes, if we take the clothes to proper laundry, you get it? They use ammonia in those type of laundry to neutralize the acid that is in the clothes. Is it taken? Yeah? Can I continue now? Can I continue?
Yes, ma'am.
All right. Let's go to basicity of an acid. Basicity of an acid. Yes. Are we together? Are we together? Basicity of an acid. Basicity of an acid is the number of hydrogen. Is the number of hydrogen atom. Basicity of an acid is the number of hydrogen atom. Is the number of hydrogen atom that can be ionized. That can be ionized in water by one molecule. By one molecule that can be ionized in water by one molecule of the acid. Are you with me? Hello? Are we together? I said basicity of an acid is the what? It is the number of hydrogen atoms that is present in the molecule of it. That is the number of hydrogen atoms that is going to ionize in water. That it is going to ionize in the molecule of that acid. Are we there? So this basicity, we can have the monobasic acid, we can have the diabasic acid, and the tribasic acid. So let's look at them one after the other. Monobasic acid. Monobasic acid. Yes. They are the acid that produce one hydrogen ion or hydroxyl ion. Just a single word. That is why it is referred to as mono. One.
One hydrogen ion.
Yes, in brackets, put hydrozonium ion. I should take that again. Monobasic acid are the acid that produce one hydrogen ion. In brackets, put hydrozonium ion. Are you with me? Per molecule in water. Hello? Per molecule in water. Per molecule in water. Are you with me? Example of that is hydrochloric acid, HCl, the hydrogen halides. Yes. HCl, the hydrogen halides. That is the combination of hydrogens with the halogens, with the group 7 elements. Like hydrogen fluoride, hydrogen bromide, hydrogen iodide. Yes. These are examples.
I wrote the channel 3 twice.
Okay, this is supposed to be 2 HNO2.
What do you want that one?
Nitric acid and nitrous. This is nitric acid. This is nitrous acid. Are you with me? So let's look at diabetic acid. Is it taking? Have you taken the examples? No, ma'am.
Yes, ma'am.
Please do. Note, right? Note. One molecule of monobasic acid. Note. One molecule of monobasic acid. One molecule of monobasic acid neutralizes 1 mole of monobasic acid neutralizes 1 mole of sodium hydroxide. 1 mole of sodium hydroxide. 1 mole of sodium hydroxide or potassium hydroxide. 1 mole of sodium hydroxide or potassium hydroxide. Is it taken? Is this understood? That is 1 mole of sodium hydroxide, 1 mole of this monobasic acid. It is going to neutralize 1 mole of sodium hydroxide. Is that okay? So diabetic acid. Number 2. Number 2. Diabetic acid produce, yes, if a monobasic acid produce 1 hydrogen ion or hydrozonium ion. What if monobasic acid produce just a single hydrogen ion or hydrozonium ion? So diabetic, as the name implies, is going to produce how many? 2. It is going to produce 2. Are you with me? Are we there together? You're not there. Diabetic acid produce 2 hydrogen ion per molecule in water. Diabasic acid produce 2 hydrogen ion per molecule in water. E.g., are we together? No, ma'am. Is it taking? Yes, no, ma'am. That's taking. Have you taken that equation? Yes, ma'am. One mole of monobasic acid, one mole of diabasic acid, one mole of diabasic acid, one mole of diabasic acid neutralizes 2 moles of sodium hydroxide or potassium hydroxide. Is it taking? If you recall, I said 1 mole of monobasic acid, it is going to neutralize 1 mole of sodium hydroxide. Isn't it? Now I am talking about diabasic. I said 1 mole of diabasic acid is going to neutralize how many moles of sodium hydroxide? It is going to neutralize 2 because it is what? It is diabasic acid. So let's look at the third one. Tribasic acid. Tribasic acid. Tribasic acid produce 3 hydrogen ions. They produce 3 hydrogen ions. Tribasic acid produce 3 hydrogen ions per molecule in water. Per molecule in water. Are you with me? Tribasic acid produce 3 hydrogen ion per molecule in water. And this is an example. Are we together? So, one molecule of tribasic acid neutralizes, one mole of tribasic acid neutralizes how many what? It's going to neutralize 3 moles of sodium hydroxide or KOA. 1 mole of tribasic acid will neutralize or neutralizes 3 moles of potassium hydroxide and sodium hydroxide. Is it taken? I should recap. Yes, ma'am. I said 1 mole of tribasic acid. 1 mole of tribasic acid neutralizes 1 mole of 3 what? 3 moles of what? Of NaOH and KOH. Are we together? So for the monobasic acid, it is 1 mole of monobasic acid is going to neutralize just 1 mole of KOH. Are we together? For dibasic acid, 1 mole of dibasic acid is going to neutralize how many moles? 2 moles. It's going to neutralize 2 moles. And for tribasic acid, 1 mole of tribasic acid is going to neutralize how many moles? 3 moles. Is it taken? Yes. Can we proceed? Can we proceed? 5 minutes more.
Somebody should so late.
We are going to solve. So, acid, base, and salt. We've talked about the acid, isn't it? We've just been talking about base. And we are going to what? We are going to salt. So, salts occur naturally in nature, isn't it? Yes. We don't even know any salts. We know. Which one? Our table salt, isn't it? Our table salt, the one we use in making our soup or stew. All right. So they occur in nature and they are deposited in their earth. Alright now. I'm just explaining. When you have to write, I will tell you. So salt, I said salt occur in nature, isn't it? Example of that one we have is sodium chloride. That is our what? Our table salt, isn't it? We also have other one, calcium carbonate. That is a limestone, isn't it? We also have marble. Yes. We also have marbles. All those and so many others. All these are found in nature. And some of them are even found in a very large quantity in their earth. Are we together? Yes. So let's look at the definition of a salt. Are you with me? Are we there together? Yes, ma'am. A salt is formed. A salt is formed. A salt is formed when the replaceable hydrogen ion. Sorry, when the replaceable hydrogen atom. When the replaceable hydrogen atom of an acid is completely or partially replaced, is completely or partially replaced by a metal or ammonium ion. Are you with me? I said a salt is formed when the replaceable hydrogen atom of an acid is completely replaced or partially replaced by metal or ammonium ion. Are you with me? Did you get that? That is definition of salt. We'll be dealing with different type of salts. But what am I saying here? I'm saying that the hydrogen ion that is present in the salt is replaced. That is, another thing is coming in to take the position of that hydrogen ion. That thing that is coming in could be a metallic ion. Are you with me? Or an ammonium ion. Are we together? Somebody is saying no. I said a salt is formed when the replaceable hydrogen ion that is in that salt, there is what? There is a replaceable hydrogen ion. When we say something is replaceable, you can remove it. You can take it away and replace it with another thing. And in this case, we are replacing the hydrogen ion with either a metallic ion or an ammonium ion. Is it taken now? Do you understand that? So let's say, for example, right, e.g., when hydrogen ion, e.g., when hydrogen ion in hydrochloric acid, when hydrogen ion in hydrochloric acid is replaced, are you with me? Is replaced by sodium ion. Is replaced by sodium ion. Are you with me? And which salt is formed? Sodium chloride, isn't it? This is what I'm saying. We have hydrochloric acid. Is it not? And this hydrochloric acid, the hydrogen here is replaced. Are you with me?
Yes, ma'am.
Is replaced with sodium. Hello? We know that this sodium is a metal, isn't it?
Yes, ma'am.
So we now have sodium what? Sodium chloride. Are we there together? When this dissociates, we are going to have hydrogen ion and the fluoride ion. Are you with me? So this hydrogen ion here is replaced. This is also dissociating to give us this. Are you with me? This one is coming to replace the hydrogen ion there. So this replacement could be complete replacement. It could be partial replacement, depending on the type of salt we are talking about. Are we together? Are we on the same page? Okay, take this. A salt is also formed. Are you taking it? A salt is also formed when the positive ion. A salt is also formed when the positive ion. When the positive ion. Put in brackets cation. Put in brackets cation. Positive ion, isn't it? The positive ions are called what? The cations of a base combined with negative ion. A salt is also formed when the positive ion, put in brackets cation, combined with negative ion, anion of an acid.
Anion.
Yes. Anion of an acid. Look, this is what happened in this reaction. Look up. We know that this is a reaction that produces salt and water only, isn't it? When sodium hydroxide reacts with HCl to give us what? To give us sodium chloride and water. This is a neutralization reaction. It is a reaction that produces what? That produces salt. So that produces salt and water, isn't it? So the sodium ion, this sodium ion from this hydroxide ion, it is combining with what? It's coming to combine with this anion to give us this sodium chloride. Is it taking? That is another definition of acid. Another definition of salt I have given to you. That is the combination of the positive anion that is present in the base, combining with the negative ion that is present in the acid to produce salt. So we are going to type of salts. Types of salt. How did you say types of salt? Types of salt. Yes, I'm listening. Sea salt. Normal salt. Normal salt. Are you with me? You know, when I was defining salt, I said there are replaceable hydrogen ions. I said there are replaceable hydrogen ions. These replaceable hydrogen ions can either be completely replaced or partially replaced, depending on the type of ion. Depending on the type of salt we are talking about. Is that okay? Yes. So I'm going to start with a normal salt. Is it taking? Normal salt is formed. Normal salt is formed when all the replaceable hydrogen atom, are completely replaced. By metallic ion or ammonium ion. By metallic ion or ammonium ion. Are you with me? Are we there together? Normal salt. For normal salt, all the hydrogen that is there is going to be replaced. Every hydrogen ion that is present in that salt is going to be replaced by metallic ion or ammonium ion. Is it taking now? All right. For example, this is next year, which is monopolycyclidity. It's going to form menopausic acid. Hello? This is hydrogen what? Hydrogen chloride, isn't it?
Yes, ma'am.
And it is forming, and you know that hydrogen chloride is a what? It's a monobasic acid. So it is going to form sodium chloride. So all of this hydrogen ion here is replaced, I've explained that earlier, is replaced by what? This metallic ion. Is it taken? Are we there together? Yes, ma'am. All right. Let's look at another example. There's another one, diabasic. Diabasic acid too. H2SO4 is a diabasic acid. Is that okay? It is going to produce diabasic. It's going to SO4. This is also a normal salt. This is an example of another normal salt. In this case, this is diabasic. Isn't it? It's going to produce two hydrogen ion. So these two hydrogen ion is this potassium K, which is metallic in nature, is replacing this what?
Hydrogen.
It's replacing the hydrogen ion. Is it taken? Is it taken? Okay, let's look at a tribasic ion that also produces normal salt. This is another example of normal salt. Are you with me? This is like another example of normal salt. And it is dibasic. This one is tribasic. This is an example that is produced from monobasic acid. This is an example that is produced from what? Diabasic. And this is another example that is produced from tribasic acid. Is it taking? H3P.
That you pronounce it. Right.
No, walking back.
Is it taking? Yes, it's right. Is someone saying something? You got tired. Say something. No. No. Are you with me? No. No. Monobasic acid. No. Monobasic acid NO2, HCl, and HNO2 produce normal salt only. Produce normal salt only. Yes, produce normal salt only. Acid salt. Acid salt. Hello. Acid salt. Acid salt is formed. Acid salt is formed. Acid salt is formed. Acid salt is formed when the replaceable hydrogen ion, acid salt is formed when the replaceable hydrogen ion in an acid is partially replaced. Acid salt is formed when the replaceable hydrogen ion in an acid is partially replaced by metallic ion or an ammonium ion. By metallic ion or an ammonium ion. Are we there? Are we together? In this case, the replacement is not a complete work. It is not a complete replacement. There is partial replacement. That is the all of the hydrogen ion that is present. Everything is not going to be replaced. Are we together? Acid salt. The first one, I said normal salt, there's going to be a complete replacement of the replaceable hydrogen ion that is present in that salt. Are you with me?
Yes, ma'am.
But for acid salt, the hydrogen ion that is there, everything is not going to go. Are you with me? So it is going to be partial or incomplete. Hello? Hello? Is it taken?
Yes.
Yes. Is that definition taken?
Yes, ma'am.
And the explanation?
Yes, ma'am.
All right. So let's look at an example. Look at this. Everyone look up. Are we together? In this case, what do we have? We have two hydrogens here, isn't it?
Yes, ma'am.
And how many hydrogen do we have here?
One.
Isn't it?
Yes, ma'am.
Now this it is only a part of the hydrogen ion. It is not undergo complete what? Complete, like not ionization. Complete replacement. Are you with me? So let me give you more examples. Is it again?
Yes, ma'am.
Are we together? Generally, basic, diabasic, and tribasic acid. Generally, diabasic and tribasic acid both form normal salts and acid salts. Generally, both the tribasic form what? They form normal salts and the acid salts. Are we together? Are we on the same page? So the diabasic acid and the diabasic and tribasic, they form two types of salts. Are you with me? They can form acid salts and they can also form normal salts. Are you with me? Because this is because such acid ionizes in stages. This is because such acid ionizes in stages. This is because such acid ionizes in stages. So we'll look at an example of diabasic acid and tribasic acid. Then we'll look at the stages. The first stage is the first stage that is going to produce the normal salt. And the second stage is going to produce the acid salt. And for tribasic, the first stage is going to produce the normal salt that produces the acid salt. I said for production of what? Production of the type of songs. They are basic and it's basic. They can produce two. Two type of songs we talk about. I think they can produce what? They can produce two type of songs. That is, they can produce the all the basic acid.